Hello and welcome to this tutorial, where I will show you how to build your own MIDI Music Box on the ESP32-S3. I will talk about how to parse a MIDI file on the microcontroller and how to send MIDI via USB. First, you will need 5 things: your microcontroller and a rotary encoder. The middle goes to ground, left and right go to digital inputs. Next, we will look at the files to put on the ESP32-S3. This umidiparser.py file from GitHub by user Bixby922. We will put this in the lib folder. It will allow us to parse the MIDI file. Next, you will need the MIDI file of your choice. Furthermore, we will need a boot.py script in which we'll tell the computer that we are a MIDI device and not an HID device. Finally, we need the code.py script, which will do the work for us. Inside the code.py file, first, we'll import the relevant libraries. If you want to know where to find them, please check my other video on how to set up the ESP32-S3 as a MIDI controller. This is how we're going to import the umidiparse file. Next, we're setting the onboard LED and our rotary encoder. I use digital IOs 9 and 10. Next, we are setting the MIDI ports. Now we are creating a buffer called RPS signal for smoothing out our rotary speed values. The variable time unit will be important later. Next, we will be passing through our MIDI file. We are preparing the event array, which will store our MIDI events, and I will focus only on node on and node off events. First, we are scanning through the MIDI file until we find a tempo, which is in microseconds, which we can turn into BPM using this equation. Then we are going to scan through the events again, and saving all node on and node off events inside our list event array, in the format event type, pitch, velocity, and duration until next event. Note that duration is actually in microseconds. Then we are starting a counter so that we can count through the MIDI events, and we are initializing 3 values we will use to compare later: time start and last node time, as well as the current position of our encoder. Now we are inside the while loop. First, we let the controller sleep for a bit, for a duration specified earlier in time unit. Then we calculate the difference between encoder positions divided by the difference in time, which is then divided by the number of steps of the encoder, which is 24 in my case. This gets appended to the end of the buffer RPS signal, and we remove the first element. Then we calculate some arbitrary speed or BPM value by taking the mean of our buffer times the size of the buffer times another arbitrary value. This is just what felt nice to me. You can of course change it. Then we clip the speed value to somewhere between 1 BPM and 240. Now it is time to measure the time and compare it to our event duration. For example, maybe our system is now 3 seconds in, the last node event happened at 1 second, while the duration until the next event is 1 second also, which has to be increased or decreased according to the ratio of the file speed and the current speed of the rotary encoder. Now we check the type of event in our event array list. If it is an on event, we will send a node on command with the event pitch and the event velocity. If it is an off event, we will send an off command. As a gimmick, we can also change the LED color according to pitch and velocity of the played node. Now we will save the time of our last node event as well as setting the counter 1 element higher. Now that I've talked about the code, it is time for a small demonstration. If you liked the video, please give me a thumbs up. If you have questions or suggestions, please tell me in the comments below. Thank you very much for listening and goodbye.